In the event that we erase the boundaries, the most captivating celestial body I recognize is the one that might be extraordinary in our sky. It is this one, Betelgeuse. It's a massive red supergiant star, and if you were to position it where our Sun is, it would extend all the way out to the orbit of Jupiter. This massive, extremely unstable star is on the verge of exploding. It's not as straightforward as it may seem. In the cosmos, these colossal events, like the most extreme supernova, could shake everything we observe and even things we don't. Though we cannot see it clearly, Betelgeuse is considered a symbol of a red supergiant star, typically much larger than our own Sun. Brian Cox, along with other astronomers, believes it might explode in a supernova soon. People have grown increasingly concerned about what's going to happen because the James Webb Space Telescope has been capturing remarkable images of the star. When exactly will Betelgeuse erupt into a supernova, and how significant will the impact be on Earth? Let's delve into a star in the magnificent Orion constellation, which shines so brightly that even ancient civilizations noticed it. The splendid star Betelgeuse resides on the eastern shoulder of the Orion constellation, ranking as the second largest star in Orion. Its name derives from this location, marking it as a shoulder star. Betelgeuse is likely one of the brightest stars visible in the night sky. In addition to its brilliant eye, the star emits an unusual red hue, which, as we will explore, signals potential danger. Humanity has long studied Betelgeuse. Greek astronomer Timon observed it long ago. At that time, the first thing people recognized about stars was their color. Timon noted that the star seemed to have a reddish-orange hue, an alarming indication. In recent years, scientists have been studying the star with even more precision, and they now have a much clearer understanding of what makes it so strikingly luminous. One of these factors is that the star undergoes substantial variations in brightness, fluctuating by as much as 0.6. Betelgeuse is a variable star, meaning its brightness changes periodically. In 2019, researchers discovered some new behaviors of the star that had never been observed before. Even though Betelgeuse didn't stop shining completely, its luminosity significantly decreased. It dimmed to a level of around 1.6, prompting experts to investigate why such an irregularity was occurring in one of the brightest stars in the sky. They were hoping to find an explanation for why Betelgeuse was behaving so erratically. According to their findings, Betelgeuse could explode as a supernova at any given moment. Brian Cox, a renowned scientist, shared this alarming assessment. As a distinguished professor of particle physics at the University of Manchester and the Royal Society Professor for Public Engagement with Science, his opinion carries weight. He also presents popular science TV shows and writes books, making his perspective well respected. Brian Cox explained that Betelgeuse seems like a ticking time bomb, one that could erupt with little warning. To support this claim, the James Webb Space Telescope has provided substantial evidence. Although several peculiarities about Betelgeuse have raised many questions, why does Betelgeuse act so strangely in terms of its variability? With the new data, Betelgeuse has earned its place as a candidate for a supernova. However, researchers still don't know when the explosion will take place. The fact that Betelgeuse's mass is nearly twice that of the Sun supports this classification. Generally, stars with at least several times the Sun's mass are considered potential supernova candidates. The plot thickens, though, because scientists have used different tools to investigate Betelgeuse, such as the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to uncover mysteries surrounding the star. What they've uncovered is still shrouded in mystery. Betelgeuse was born on August 31 a very long time ago, and since then, the star has been offering strange signals that keep its future uncertain. What did they discover? They detected peculiar light waves emanating from the star, which raised further intrigue. But this wasn't the only strange occurrence. It brings us back to the fact that Betelgeuse is a variable star, fluctuating in brightness. There were reports that Betelgeuse had regular darkening episodes akin to sunspots on our own Sun, but the cycles were different. It shifts between bright and dim phases twice as rapidly as it once did, another odd sign that Betelgeuse is misbehaving. Researchers observed that in February 2021, the star's dimming cycle reached a brightness band of plus 1.61. This was not long after the star had experienced a massive dimming event, marking the beginning of its abnormal behavior and raising alarms that Betelgeuse might be nearing the end. The significant dimming between 2019 and 2020, reaching its lowest level, made many experts convinced that the star would explode within the next 100,000 years. But when Betelgeuse brightened once more after this unprecedented dimming, things became even more bewildering. As physicist Andrea Dupree from the Harvard Smithsonian Center for Astrophysics noted, The star was now 150% brighter than usual, making it the seventh brightest star in the sky. Researchers were astonished to see a red glow emerging from the southern part of the sky. The situation only became more puzzling. This development sparked numerous theories about the cause of Betelgeuse's great dimming. It's essential to highlight that not every star radiates the same red glow that Betelgeuse does. This glow marks Betelgeuse as a red supergiant star, which is the final phase of a star's life before its death. This red hue is the result of a surface temperature around 3,500 Kelvin, significantly cooler than the outer layer of the Sun, which is around 5,500 Kelvin. Since Betelgeuse is cooler than the Sun, it radiates less energy per unit of surface area, even though it is much larger and on the brink of exploding. We should also consider the extraordinary dimming event that Brian Cox questions. Does it really mean Betelgeuse will go supernova? The fact that Betelgeuse is already in its red supergiant phase indicates that it is nearing the end of its life as a star. A star in this phase will often dim as it dies, and this is something scientists can detect. However, Betelgeuse's recent unusual behavior has caused scientists to be even more focused on monitoring it. Today, multiple telescopes are focused on this mysterious dimming event, trying to gather more insights. Things continue to get even more intriguing, as researchers still don't have a deep understanding of Betelgeuse's behavior. Using cutting-edge instruments, scientists are watching the star closely. The James Webb Space Telescope has been one of the most valuable tools since its launch in 2021, helping astronomers gather new valuable data about Betelgeuse. The telescope's images of the star's remarkable dimming have shown that the event caused an enormous mass ejection, roughly 400 billion times more significant than a typical coronal mass ejection. Despite the fact that Betelgeuse is undoubtedly approaching its demise, scientists continue to watch for signs of when it will finally explode. No one knows the precise moment. Betelgeuse is believed to be considerably more massive than the Sun, and researchers expect this brilliant red star to shine for the next decade. As the world awaits Betelgeuse's inevitable explosion, scientists remain vigilant, tracking its fluctuations in brightness, mass ejections, and surface activity. The event will be one of the most significant astronomical occurrences in human history, offering an unparalleled opportunity to study stellar evolution in real time. When Betelgeuse finally detonates, the explosion will unleash a tremendous burst of energy, including high-energy neutrinos and gravitational waves. These signals will travel across space, reaching Earth and providing scientists with invaluable data about the inner workings of a supernova. Observatories worldwide, from neutrino detectors buried deep underground to radio telescopes scanning the cosmos, will be poised to capture and analyze the event. The most striking aspect of Betelgeuse's explosion will be its luminosity. For weeks, if not months, the supernova will be visible even during daylight hours. At night, it will rival the full moon, casting eerie shadows on the ground. Its brilliance will gradually fade, leaving behind a nebula, a glowing remnant of the once mighty star. Astronomers believe that Betelgeuse's supernova will eventually give rise to a neutron star or, if the collapse is powerful enough, a black hole. Either outcome will offer further insights into the life cycles of massive stars and the formation of exotic cosmic objects. For now, Betelgeuse continues its slow march toward its fate, tantalizing scientists with its unpredictable behavior. While the exact timing remains uncertain, one thing is clear: when the explosion finally occurs, it will be a spectacle unlike anything seen in modern times, a dazzling reminder of the universe's dynamic and ever-changing nature. Until that day arrives, we can only watch and wonder, gazing up at Orion's shoulder and imagining the cosmic fireworks that await. Stellar systems. In the meantime, scientists continue to observe Betelgeuse, piecing together the puzzle of its future. With each new discovery, the mystery surrounding it grows deeper, expanding our understanding of the universe. With every piece of the puzzle uncovered, perhaps in the years to come, we will witness one of the most extraordinary events in the cosmos, the transformation of Betelgeuse from a massive red supergiant into a breathtaking supernova. Until then, the sky will remain a canvas of wonder, with Betelgeuse shining brightly as a reminder of the fleeting nature of life in the universe. Betelgeuse's transition into a supernova is an event that will capture the attention of astronomers and skywatchers alike. Even though we are unsure when exactly this transformation will occur, the star's current instability has sparked a wave of speculation about its future. The advanced instruments and technologies at our disposal, such as the James Webb and Hubble Space Telescopes, have provided astronomers with unprecedented insights into the behavior of this remarkable star. As Betelgeuse's brightness fluctuates and its erratic changes continue, scientists are meticulously studying the data in the hopes of understanding what triggers these shifts. The star's extreme variability could be a precursor to the violent explosion that will ultimately mark the end of its stellar life. Whether Betelgeuse will explode within the next few years or in a much longer time span remains uncertain. One thing is clear: the universe is full of cosmic surprises, and Betelgeuse's eventual demise will be a spectacle that brings new opportunities for discovery. Throughout the centuries, astronomers have observed and studied countless stars, but few have garnered as much attention as Betelgeuse. Its immense size, variable brightness, and unusual color have made it a subject of intense research. As a red supergiant, Betelgeuse is already in the final phase of its life cycle. The star's massive size means that it will eventually exhaust its nuclear fuel, leading to its ultimate collapse and subsequent explosion into a supernova. This explosive event will release an astonishing amount of energy, significantly altering the surrounding cosmic environment. Despite the many uncertainties surrounding the exact timing of Betelgeuse's supernova, astronomers agree on one thing: the star's eventual demise will be one of the most significant cosmic events to occur in our lifetime. The data being collected by the most advanced telescopes today is helping to unravel the mysteries of the star, providing crucial information about the processes that occur during the final stages of a star's life. By studying the behavior of Betelgeuse, scientists can gain deeper insights into the broader mechanics of stellar evolution. Moreover, the explosion of Betelgeuse will likely leave behind a lasting impact on the surrounding space, enriching the interstellar medium with heavy elements that will eventually be incorporated into new stars, planets, and potentially even life forms. This cycle of creation and destruction is a fundamental aspect of the life cycle of stars, and Betelgeuse's supernova will be a prime example of this cosmic process. As we continue to monitor Betelgeuse and other stars in similar stages of evolution, astronomers are using cutting-edge technology to better understand the forces at play. The James Webb Space Telescope, with its unparalleled ability to observe distant objects in the universe, is providing a wealth of data that will shape our understanding of stellar dynamics. The images and measurements captured by this telescope are helping to shed light on the complex mechanisms that drive a star's evolution, from its birth to its ultimate demise. Although the death of a star may seem like a cataclysmic event, it is, in fact, a crucial step in the ongoing cycle of stellar evolution. The elements released during a supernova contribute to the formation of new stars, planets, and potentially even life. In this sense, the death of Betelgeuse, and stars like it, is not an end, but rather a transformation that fuels the birth of new celestial bodies. Betelgeuse's supernova will play a significant role in the ongoing evolution of the universe, contributing to the creation of the building blocks for future generations of stars and planets. Until the day Betelgeuse finally explodes, astronomers will continue to observe and study its behavior, piecing together the clues that will help them predict its future. The star's unpredictable dimming and brightening cycles, as well as its other unusual behaviors, make it a fascinating subject of study. With every new discovery, scientists are learning more about the processes that govern the life cycle of stars, and, by extension, the evolution of the universe itself. The mystery surrounding Betelgeuse's fate serves as a reminder of the vastness and complexity of the cosmos. The universe is filled with untold wonders, and the study of stars like Betelgeuse allows us to glimpse the incredible processes that shape the fabric of reality. As we continue to explore the cosmos and deepen our understanding of the forces that govern it, we are reminded of the fragile, transient nature of life itself. The stars, including Betelgeuse, shine brightly in the night sky, offering a glimpse into the extraordinary and ever-changing universe in which we live. Betelgeuse's behavior continues to puzzle scientists as they piece together the mysteries surrounding its eventual fate. While the exact moment of its supernova remains uncertain, its peculiar fluctuations in brightness offer valuable clues into the intricate processes that govern stellar life cycles. As a red supergiant, Betelgeuse is already on the cusp of its dramatic end, a fate shared by many massive stars in the universe. Understanding how and why Betelgeuse undergoes such erratic changes can help astronomers better understand the broader patterns of stellar evolution. The star's unpredictable dimming and brightening events suggest that it may be undergoing internal changes as it nears the end of its life. These fluctuations may be a sign of complex processes occurring in its core as the star exhausts its nuclear fuel and prepares for the inevitable collapse. Such transitions are essential for researchers to study, as they can reveal critical insights into the mechanisms of supernovae, the explosive deaths of stars. When Betelgeuse does eventually explode, the resulting supernova will likely release an immense burst of energy, producing vast amounts of light and radiation. This explosion will scatter elements like iron, carbon, and oxygen into the surrounding space, enriching the interstellar medium with heavy elements that can eventually contribute to the formation of new stars and planets. These elements, forged in the hearts of stars, are vital building blocks for the creation of life as we know it. In this way, the death of Betelgeuse will serve as a cosmic recycling process, ensuring the ongoing evolution of the universe. Scientists are also interested in how supernovae like Betelgeuse's can impact their surrounding environments. A supernova's shock waves can trigger the formation of new stars by compressing nearby gas and dust. This can lead to the birth of new celestial bodies, potentially resulting in new planetary systems, and possibly life. Understanding the complex relationship between the death of massive stars and the birth of new ones is crucial for a complete picture of the cosmos' dynamic nature. As astronomers continue to monitor Betelgeuse, they also prepare for the day its inevitable supernova occurs. Observatories around the world, from ground-based telescopes to space-based instruments like the James Webb and Hubble Space Telescopes, are poised to capture every moment of this extraordinary event. When Betelgeuse finally explodes, it will be one of the brightest supernovae ever recorded, potentially visible even during daylight hours. Scientists predict that when the explosion happens, a brilliant flash of light will first reach Earth, followed by waves of radiation across the electromagnetic spectrum. This cosmic event will not only be a spectacular sight for skywatchers but also a treasure trove of scientific data. The insights gained from Betelgeuse's supernova will help refine our understanding of stellar evolution, supernova mechanics, and the distribution of elements throughout the universe. Moreover, Betelgeuse's supernova will provide valuable opportunities to test existing astrophysical models. By analyzing the patterns of radiation and energy release, astronomers can refine their theories on how massive stars end their lives. The study of this event could also shed light on neutron star and black hole formation, as Betelgeuse's core collapse will likely lead to one of these dense remnants. Despite its impending explosion, Betelgeuse poses no direct threat to Earth. At approximately 640 light-years away, it is far enough that the energy released will not harm our planet. However, its supernova will have profound effects on the interstellar medium, influencing the formation of future stars and planetary systems. Some of the material ejected from Betelgeuse's explosion may one day contribute to the creation of new worlds, perhaps even ones capable of supporting life. As we continue to gaze up at the night sky, Betelgeuse remains a symbol of cosmic impermanence. Its eventual demise will mark the end of a celestial era, but it will also illuminate the ongoing cycle of stellar birth and death that has shaped the universe for billions of years. While we do not know exactly when this event will occur, the scientific advancements of today ensure that when it does, we will be ready to witness and learn from one of the most remarkable astronomical events of our time. Until that day arrives, Betelgeuse will continue to shine, sometimes dimming, sometimes brightening, reminding us of the ever-changing nature of the cosmos and the vast, unfolding story of the universe.